Everyone, welcome to HDL Laboratory. In this session, we will be understanding about realization of logic gates. Coming to the introduction. The aim of today's session is to write a Verilog code to realize all the logic gates that are present. Firstly, this is the symbol of two input AND gate. This is the symbol for two input OR gate. This is a symbol for NOT gate. In AND gate, suppose the inputs are A and B, the output will be A into B. In OR gate, if the inputs are A and B, output will be A plus B. And for NOT gate, if the input is A, the output will be A bar. And this is the symbol for two input NAND gate, which is the NOT operation of the output of the AND gate. So this is indicated by this symbol. If the inputs are A and B, the output will be A B bar. This is the symbol for two input NOR gate. This is the NOT operation of the output of the OR gate. And if the inputs are A and B, the output of this NOR gate will be A plus B bar. This is symbol for two input XOR gate. If the inputs are A and B, the output will be AB bar plus A bar B. This is the symbol for XNOR gate. If the inputs are A and B, the output will be A bar B plus AB bar whole bar, which is nothing but just a reverse of this. The NOT operation of the output of XOR gate will be the output of this XNOR gate. So this is about the various symbols of the logic gates. Coming to the basics of logic gates. In this slide, we have considered each and every gates and inputs and the outputs whatever we are getting. So firstly, we'll be considering an AND gate. There are two inputs A and B. Let's say the output is F. The output of the AND gate is F equal to A into B. So we'll be considering all the various values of A and B and finding the value of the output for this AND gate. So for A and B equal to 0, 0, 0 into 0 is 0, so output will be 0. 0 into 1 is 0, so we have output as 0. Next, when the two inputs are 1 and 0, we'll have the output as 0 itself. When both the inputs are 1, the output is 1 because 1 into 1 is 1. So this is about the AND gate. And coming to OR gate, the two inputs can take values from 0 0 to 1 1, that is 0 0 0 1 1 0 and 1 1. Similarly, how we followed for the AND gate, the same procedure will be followed for OR gate. So for OR gate, the output is the sum of the inputs, that is A and B. So we have F is equal to A plus B. So for 0 and 0, we have output as 0. And for 0 and 1, and also for 1 and 0, we have outputs as 1. For 1 and 1 also, we have output as 1. Next, coming to the NOT gate, which is also called as inverter. The output is nothing but the complement of the input. So we have when input is equal to 0, the output will be 1. When input is equal to 1, the output will be 0. So next we have NAND gate. We'll write an AND gate with a circle. So this is the symbol for NAND gate. Inputs are A and B. Output is represented as F. Various values of inputs are ranging from 00 to 01, and this is nothing but the complement of this. So you can observe here A into B whole bar it is. So 0 into 0 is 0. 0 complement is nothing but 1. So we write 1. 0 into 1 is 0. Complement of 0 is 1. So we'll write 1. So likewise, the output values are 1, 1, 1 and 0. And for NOR gate also, it is the complement of OR gate. So you can observe for 0 value of output when inputs are 0 and 0. Here for inputs 0 and 0 we have 1. And for values of inputs 0, 1, 1, 0 and 1, 1, we have 1 over here. The complement of that is 0. So we have 0 over here. And coming to the XOR gate. XOR is nothing but F is equal to AB bar plus A bar B. So when two inputs are same, that is 0, 0 and 1, 1, the output will be 0. When two inputs are different, the output will take a value 1. Next, we have XNOR gate, which is represented like this. This is nothing but the complement of XOR gate. Alright. In this slide, we have a VERILOG code for logic gates realization. Firstly, we'll be declaring a module. So this first we'll write module, and next we have written gates. This gates is nothing but the module name. Module is nothing but the keyword. Now, while giving names to the module, we're not supposed to give names or words that are the keywords in this library. So gate is not a keyword. So we have given gates as a module name, and in this module we have two inputs, and we are realizing all the gates: AND gate, OR gate, NOT gate, NAND, NOR, XOR and XNOR. So totally we are realizing 7 gates. So we have 7 outputs, and we have named it as O1, O2, O3, O4, O5, O6 and O7. So in this module itself, we'll be first writing the inputs, that is I1 and I2, and next followed by the outputs, and this will be ended by a semicolon. Next, we will declare the inputs and outputs. Here, input is a keyword. Alright, and the inputs are I1 and I2. Next, we'll be declaring outputs. So for declaring outputs, the keyword is output. We'll declare output O1, O2, O3, O4 and so on till O7. Next, we will have to assign values to this outputs. Okay, so how will we do that? First, we'll be realizing the AND gate. AND gate's output we have taken as O1. So we need to assign a value for O1 now. So for assigning, we have keyword assign. Assign O1 is equal to I1 and I2. This is for AND gate. Next, we'll realize OR gate. So OR gate's output we'll take it as O2, and we'll assign it as assign O2 is equal to I1 ORed with I2. Next we have NOT gate. NOT gate output, we'll take it as O3 and we'll assign it as assign O3 is equal to negation of or the complement of I1 or I2. You can take whichever input you want. Here we have taken I1. Next we'll realize NAND gate. NAND gate output we have chosen as O4. So we'll assign it as assign O4 is equal to complement of the AND operation. That is I1 and I2. Next we'll realize NOR gate. NOR gate output will take as O5 and we'll write assign O5 as negation of or the complement of I1 ORed with I2. Next will be realizing XOR operation. XOR operation is represented by a cap symbol, as you all know. So the output of that particular gate we have chosen as O6. So we'll write assign O6 is equal to I1 XORed with I2. Next we have realization of XNOR gate, that is complement of the output of XOR gate. So we'll write complement of I1 gap I2. Next, you might be wondering what is this AND module? We have initiated the module gates over here. This cannot be left as it is. It should be ended or the loop should be complete. Otherwise, this program will enter an indefinite loop. Hence, we will write end module. So this is it about the VERILOG code for realization of logic gates. The simulation and some waveforms of this particular program will be shown to you in the next session. Thank you all.